So this is Algebra 1, Section 7.4. It's called Radical Expressions. It's on page 419. Oh. Thank you. We're waiting for this to come up. Okay, I'm on page 419, and I apologize. It's now coming up. We'll start by writing radical expressions, if you would. Okay, radical expressions. Now we've actually talked about this a little bit. Radical expressions contain a radical, such as a square root. Okay. They also contain a variable, most oftentimes. They can, which we haven't talked a lot about. Now, we've already talked about simplifying radical expressions, and that was that worksheet that we had. Okay, what does this mean? It means that no radicand, remember radicand is the radicand is the thing underneath the radical sign, right? No radicand can have a factor that's a perfect square. Okay? That's the first thing. No radicand can have, so the square root of 8 you cannot have. Okay? Okay, so maybe I'll give that example to you. So if we have a square root of 8, that is not simplified. From our worksheet, we learned that this is the square root of 4 times the square root of 2, and this is 2 square root of 2. Any questions about that? So we can't have a radicand that has a factor that's a perfect square root. All right? The second thing is no radicand can contain a fraction. All right? So if you have the square root of 4 sevenths, can't do it. This is really the square root of 4 and over the square root of 7. This is not considered simplified. Okay? Because now this brings up the third one. No radical in the denominator. Remember that? What do we call it when we remove it? What do we call it when the process to remove a radical from the denominator? Rationalizing the denominator. Thank you, Ryan. So we would take this times the square root of 7, the top and bottom. We'd have the square root of 20. What is the square root of 4? 2. So I'd have 2 square root of 7 over 7. Do you remember that? And this is called rationalizing the denominator. Once you've done these things, then the radical is considered simplified. Okay? All right? You remember that? Okay? Let's take another one, just to remind ourselves. What would be the square root of 80? What goes into 80 that has a perfect square root? 9 actually does go in it, but there's another one that's bigger. So after 9, what's the next one? 16? 16? Does 16 go into 80? I don't think so. Actually, it does, but there's one. Is there one bigger? I think 16 is the biggest, isn't it? So it'd be the square root of 16 times the square root of 5. What's the square root of 16? 4. So my answer would be 4 square root of 5. By the way, this is called the product rule. Do you remember that? The product rule says if the square root of AB equals, we don't need if, the square root of AB means the square root of A times the square root of B. Remember that? Or vice versa. Okay? All right, so we're going to use that concept now and we're going to do something a little different. We're going to bring in variables. Okay? So let me show you what we're going to talk about. The square root of 90 x to the third power, y to the fourth power, z to the fifth power. Okay? Now, not only are we going to break down 90, but we're going to break these other ones down too. Allie, you understand that?
Wouldn't you use substitution?
No. Okay, folks. We know how to do the square root of 90, but I'll remind you in just a minute. How many x's do we need to have a perfect square root? 2. How many y's do we need to have a perfect square root?
2.
How many z's do we need to have a perfect square root? We always need 2, right? We got more than 2, don't we? All right? So what I'm going to do is I'm going to start breaking this up. Tell me something that goes into 90 that has a perfect square root. How about 9? Very good. And that's 9 times 10, square root of 10, right? How many x's do I need to have a perfect square root?
2.
All right. How many are left over if I have 3 of them? I have 1 left over. Is that correct? Does everybody see this? So I broke up x to the third as x squared times x, right? How many y's do I have to have?
2.
2. And I have 4, right? So I have 2 sets of y squareds, right? Because y squared times y squared is y to the fourth. How many z's do I have to have? Same thing, right? 2. And I have how many? I have 5. So I broke it down like this. Does everybody see this? I break it down so that each one has 2.
Can you go back to the y's?
Can I go back to the y's?
Yeah.
I have y to the fourth, right? I need 2 y's to get a perfect square root.
Uh-huh.
So I break it down so this has y squared and y squared. Each one of these has a perfect square root. And there's 4 of them, right? So these will always add up to whatever number's there, right?
Alright.
So this is z to the second times z to the first, right? This is a lot of work, isn't it? Well, let's see what our answer is. The square root of 9 is 3. And the square root of 10 stays underneath, right? Now notice I made this really long because there's going to be some coming out, some going in, right? Okay? The square root of x squared is x. I'm going to come back to that in a minute. This x did not come out. I did not have enough of them. What's this y? Y, and this is y. Y times y is y squared. How many z's? Z squared. This is a z. This is a z. So that's z squared. And there's 1 left inside. Now, that's not very fun, is it? I have one more thing to add before we talk about this. This right here. Whenever we have an even exponent, and we go to an odd exponent, so we went from 2 to 1, we have to put an absolute value sign around it. Because it has to be positive. Now don't think I'm just going to turn you loose without talking about this. This is a lot of work, isn't it? Wouldn't it be nice if we had a shorter method?
Yes.
All right, I'm going to give you a shorter method. You better learn it. Here we go. Take this number, each one of these numbers, these exponents, and divide them by 2, the magical number. And whatever whole number goes into it, I'll give you an example. If I have x to the 23 power, I'm going to take 23 divided by 2. All right? Goes in here once, 2, 13. It goes in here what? Whoops, this is 0. 3, 1, 2, and I get a remainder of 1, correct? This means that 11 x's come out and 1 stays in. This number right here tells you how many come out. This number right here tells you how many stay in. So 11 x's come out, 1 stays in. Let's check it. 3 divided by 2 is 1 with 1 remainder, correct? So 1x comes out, 1 stays in. 4 divided by 2 is 2 with no remainder, right? So 2 y's come out, no y's stay in. 5 divided by 2 is 2, right? So 2 come out and a remainder of 1, 1 stays in. You see how that works, Allie? That's the quick way of doing it. Now let's try that, Allie. All right, let's try this one. 32 r to the 2nd, k to the 4th, t to the 5th. All right, you ready? I'm going to go down here a little bit. All right, how do I do 32? Well, I believe 32 is 16 times 2. Is that correct? Is that correct?
Yes.
All right, the square root of 16 is 4, square root of 2, right? All right, I have my numbers, correct? All right, let's do this. Let's do this variable thing, okay? Notice that I give room here and I give room here, so I can put things. You ready, Braxton?
Yep.
All right, here we go. That's 2, right? 2 divided by 2 is 1. So we have 1 arm comes out, and we're going from an even to an odd. So we put an absolute value sign around it. Okay? So 1 r comes out. How many go in? What's the remainder? 2 divided by 2 is 1. What's the remainder? 0. There's no remainder. There's no r's inside. Let's do the k. 4 divided by 2 is?
2.
2. So 2 k's come out. I'm going to scrunch this. 2 k's come out. How many go in? What's the remainder? There's none. All right. T to the 5th. 5 divided by 2. How many come out? How many go in? 1. When we're doing square roots, the most that you'll have stay in is 1. The most you'll have stay underneath the radical is 1 when we're doing square roots. We good? Okay? All right, would you try this one? Watch your absolute values. Remember when I go from an even to, and it comes out and we go to 1, or like a even to odd, 4 to 1, something like that, then we do it. Okay? All right. Here it is. 56 x y to the 10th z to the 5th. What goes into 56? 9. Right?
No, 54.
Yeah, 54. 9 doesn't work, does it?
No.
How about 4? 4, does 4 go into 56? How many times? I think it's 14, isn't it? Is it 14? Okay. So this is 2. I leave some room. And 14. I don't think I left enough room again. Okay. All right. How many x's are there? 2 doesn't go into 1, does it? So where does the x go?
Inside.
Inside. Okay. 10 divided by 2 is 5. Is that odd? Then it's an absolute value because I went from an even number, which is 10, to an odd. How many go underneath? None. Because 10 divided by 2 it has a remainder of 0. Okay? All right. How many z's come out?
2.
2. That's even, so we don't have to worry about it. How many stay in?
1.
There you go. Tater, do you have any questions?
Nope.
All right. Tater, do you remember how to rationalize the denominator?
Yeah.
All right, let's see if you do. Let's see if you do. Okay? Let's do simplify again. I'm on number 5, correct? If I have 4 square root of 2 over the square root of, let's go 3 square root of 3, okay? All right, so I have 4 square root of 2 over 3 square root of 3. How do I rationalize this, Tater? Tater, what do I do? Anybody? Caden.
You take both the top and the bottom times the square root of 3.
Thank you, Caden. Might want to learn that. What do I have on top then, Ryan?
4 square root 6.
What do I have on bottom, Allie?
9 square root. Or no. 3
Times the square root of 9, right? What is the square root of 9? It's 3. So 3 times 3 is? So my answer is 4 square root of 6 divided by 9. Tater, do you have any questions about that?
Nope.
Well, good. You need to learn that. Okay. All right. So what I'm about to show you is how to do a conjugate. All right? Because we're going to have to rationalize something like this. 3 minus the square root of 2. All right? You cannot just multiply by the square root of 2. All right? What we have to multiply is what we call a conjugate. C-O-N-J-U-G-A-T-E. A conjugate. Oops. I don't know why I put that there. A conjugate in this case is 3 plus a square root of 2. So let me explain a conjugate to you. Ryan, these two numbers are the same, and these two numbers are the same. What changes?
Sign.
The sign. Okay, have you guys ever heard of FOIL? Has anybody heard of FOIL? Just Ashley. Okay? FOIL stands for first. Okay? It's just cooling off. So what I do is I take the first term times the first term. This is how we distribute. Notice I changed this to plus and negative. Did anybody catch that?
Yep.
So I take the first term times the first term and I do it on top. What is 3 times 3?
9.
9. Okay? O stands for outer. Okay? Outer. And I do that underneath. So these two are on top, these two are on bottom. What I mean by bottom is this times this. Okay? So, I can't take a whole number times a rational, so it's just 3 times the square root of 2. You following this, Caden? Then the I stands for inner, Caden. Ooh. That would be these two. And it's also done below. See how these two lines are below? All right? So I would take 3 times the negative square root of 2, which is a negative 3 square root of 2. And last, but certainly not least, I go back up top and I take L stands for last, the last two terms. So I have a negative square root of 2 times the square root of 2, which is a negative square root of 4. Correct? Now, why do we multiply by conjugates? Here's why. Tell me about these two. They are opposites. Whenever we add opposites together, what do we get? 0. And so I have 9 plus, but what is a negative? What is the square root of 4? 2. So what is 9 plus a negative 2? 7. Okay? 7.
That's a lot of work.
Yes, but look what it did. It gave us a number that is not rational, or excuse me, irrational. It doesn't have a radical, does it? Okay, so this is how we, watch how we do this then. This is how we rationalize something in the denominator that has something like this. So let's say that we have 5 over 2 minus the square root of 2. You see that? This cannot be, you can't just multiply by the square root of 2 because you'd have to use the distributive property. It would not get rid of the radical in the denominator. So we have to multiply anytime you have a whole number, a rational number, add or subtract a radical, we multiply by the conjugate, which is 2 plus the square root of 2. Remember, it has the same numbers. We just changed the sign. Does everybody see that? Does everybody see that? Is there anybody that does not? So Tater, on the top, I have 5 times 2 plus the square root of 2. And on the bottom, I have 2 minus the square root of 2 times 2 plus the square root of 2. Questions? All right, here we go. On the top, since this is not a quantity, we're just going to distribute this. Do you see that? So I'm going to have 10 plus 5 square root of 2, because I can't put these two together. This one's whole, this one's a radical. All over. Now I use this method that I just showed you, FOIL. So I'm going to do this off to the side. I wish I would have left my room. I'm going to do this off to the side. 2 plus a negative square root of 2. 2 plus a negative square root of 2, and 2 plus the square root of 2. Do we all see that? So here's what I get. Top first. 2 times 2 is 4. Outer is down here. 2 times the square root of 2 is 2 square root of 2. Inner is a negative 2 square root of 2. And last is a negative square root of 4. Did everybody see where I got those numbers? And it looks like a face. Have you noticed that? It kind of looks like a face. Okay, let's do the top. Is 10 plus 5 square root of 2. And the bottom is 4. What happens to the middle terms? What happens to the middle terms? They cancel out. And so I have 4 plus a negative 2. What is 4 plus a negative 2? What is 4 plus a negative 2? 2. Okay, now, you ready? This forms a triangle, doesn't it? I call it a triangle. I have to look at the Bermuda Triangle here. If all 3 of these numbers have something in common, you can cancel it. But it has to be all 3. 10 and 2 have something in common, it's 2. But 5 and 2 do not. 5 and 10 have something in common, but still 5 and 2 do not. Therefore, you cannot simplify this. If this was a 6, you could simplify dividing all 3 numbers by 2. It has to be all 3 numbers. Okay. All right? Now, we'll get to more of that in a little bit. Okay? I just now want to talk about addition and subtraction. You have win time tomorrow, correct? So I want to get to this so we can work on it, but I might have to go over some of this tomorrow if you ask me to. Okay? All right. I want you to look at this problem right here. It's going to say simplify again. So this is number 7. And it's going to say 5 square root of 2 plus 7 square root of 2 minus 6 square root of 2. Folks, you remember like and unlike?
Mhm.
These are all like because they have the same radicand. They have 2 underneath the radical, 2 underneath the radical, and 2 underneath the radical. If they have the same radicand, you can add and subtract them. So this is 5 plus 7 is 12. Minus 6, or plus a negative 6, is 6 square root of 2. Notice the radicand stays the same, but the numbers in front change. Okay?
That was a lot easier than that.
Oh yeah, this is a lot easier, right? So if I have 10 square root of 7 plus 5 square root of 11 plus 4 square root of 7 minus 6 square root of 11. Okay, I change them all to positive. First thing I do, because I'm going to rearrange them, you'll notice that this guy and this guy are like because they have the same radicand. This guy and this guy are like because they have the same radicand. Are we following that? Allie? Okay, Allie. 10 square root of 7 plus 4 square root of 7 is?
14 square.
Alright, good. And 5 square root of 11 plus a negative 6 square root of 11 is negative 1 square root of 11. Very good. Any questions? Now, you think you got all that figured out, right? And then something like this happens. 4 square root of 54 plus 2 square root of 24. And you look at that and you go, they're not like. So I just leave it like that. Well,
We're wrong.
you got to simplify first and then see if they're like. 54 has the square root of 9 times the square root of 6. Is that correct? And 24 has the square root of 4 times the square root of 6. Is that true? Both numbers can be broken down. All right. So now I have 4 times 3 times the square root of 6. And I have plus 2 times 2 square root of 6. Is that true? So this is 12 square root of 6 plus 4 square root of 6. And looky there, folks. Are those two like?
Yes.
Yes, they are. And so I have 16 times the square root of 6. Okay? Now, guys, don't confuse that with this. 2 square root of 6 times 7 square root of 3. Is this the same thing? What's the difference? This is multiplication, guys. And so I can multiply the two whole numbers and I can multiply the radicands. Okay? It's different than addition, isn't it? We've done this before, right? So this actually can be 14 times the square root of 9 times the square root of 2. Who forgot to simplify that? 3 times 14 is 12. 42 square root of 2. Do you see the difference? Yes or no? Okay. And then the good old author, he will combine them. Well, this is the square root of 2, correct? He's going to take, he's going to take this times this, and this times this. You're going to have to distribute. So you're going to have to do the combo of multiplication and then look to see if you can add it. So I'm going to distribute. This is like FOIL only one time. Remember FOIL? This is only FOIL one time. So I have, what's these two multiplied by each other? Charlie? 3 square root of 2 times 4 square root of 3. What do you get? 12 square root what? how about square root 6? 2 times 3, right? Tate, I'm going to come back to you. What's this times this? This times this.
18 square root 2.
Nope.
No.
Square root what? 4. You see how when you add them, it's the square root of 2, but when you multiply them, it's the square root of 4. Is that crazy? I'm not done yet. This is 12 square root 6 plus, this is 2, right? 2 times 18 is 36. Can I add these two together? Yes or no? No. They have to have the same radicand in order to, this one doesn't even have a radicand, so you cannot. Okay. There's a lot of information in there, isn't there? Okay, here's your assignment. And I'll give you the next 2 days to work on it. Ask questions, okay? Page 424. Numbers 2 through 52, and I just want on 52 just A and B, and that's all even. Okay? Then you're going to do 53 through 62 all. And then we're going to go 64 through 72 all. Okay? It is due next Monday, or excuse me, Tuesday, because we don't have school on Monday. We'll review and then we'll take a test. The test is pretty complicated, obviously. Okay?